Hi, this is Math 1340, and this video is over chapter 3.3. We're going to start looking at polynomial division. And there's two types of ways of doing polynomial division. First is long division. We do it a lot like we do regular long division. It can be long and kind of tedious sometimes. Um, but with certain types of divisions that are really useful in terms of finding zeros, would be what's called synthetic division, and it's a quicker way of doing division, and you do it when you have um, you're dividing by some polynomial that's linear, and allows you to check zeros and to see if numbers are zeros. All right, so first, before I do anything, I want to go over a little bit of just regular long division. If you had 7 and you're dividing that into 38, the process is you count how many times 7 goes into the first number. In this case, it goes into 0 times. So then we go to the two numbers. It goes into 38 5 times. And then you multiply the 5 and the 7. So you get 35. Then you subtract. So you add number 3, you bring down the 0. Okay. At this point, we're on the at the decimal. So everything after this is going to be after the decimal. So 7 goes into 30 4 times. Multiply across, you get 28. And when you subtract those, you get 2. I'm going to come over here. And 7 goes into that twice. Then you multiply, you get 14. Come down, where you subtract, you get 6. So it'll be 0, 60. And so on. And we're getting, a longer and longer decimal. But when we got here, when we got to the 3, a lot of times, if you remember, that 3, we just call that the remainder. And we could write this as 5 with a remainder 3, or if you think about it, it's going to be 5 plus 3/7. Okay. So eventually, our decimal will eventually come out to the decimal for 3/7 there. Now, the process for long divisions with polynomials is very similar. We use the same sign. So x plus 5, long division sign, 2x squared plus 3x minus 35. Okay. One of the key things is to make sure that every degree for each term is there, starting with the highest degree. So x squared term is there, x term is there, constant term is there. Now we start with this process. We take 2x squared and we divide it by just the x. We get 2x. That comes up top. Then we multiply through like we do in normal calculation. So 2x times x is 2x squared. 2x times 5 is 10x. Then we subtract. And we get 0. That has to be 0. If you're not getting 0 there, then that's a major problem. And then we got 3 minus 10 be a negative 7x. So now we go through the process again. Negative 7x divided by x is negative 7. Then we multiply through, we get negative 7x. And we get negative 35. Then when we subtract, that's going to make these positive. So 7x minus negative 7x plus x is 7x is 0. Negative 35 plus 35 is 0. And so our remainder here is 0. So the time you know when to stop is when when you divide your negative 7x by x, you're getting a whole constant. That's the last round of going through that iteration. What this means is that x plus 5 times 2x minus 7 equals 2x squared plus 3x minus 5, 35. So you're basically factoring your polynomial by doing this. So the next one, we have 4x plus 9. That's going to divide into 8x squared plus 6x minus 25. So start with 8x squared over 4x is 2x. Multiply through, you get 8x squared plus 18x. Subtract. You get 0. And 6 minus 18 would be negative 12x. Negative 12x over 4x, negative 3. Okay, this is going to be the last iteration because of the negative. You're just getting a whole number there. Well, number without a variable. Constant number there. Negative 3 times 4x is negative 12x. Negative 3 times 9 is a negative 27. Subtract. It's going to be 0. And this is going to be negative 25 plus 27 will be 2. Okay, so here your remainder is 2. Okay. What this means is that 4x plus 9 times 2x minus 3 plus a 2 over 2x minus 3 is going to be what gives 8x squared plus 6x minus 25. Okay. So this doesn't factor as well. And so that's one way to tell whether something is factoring is by dividing and seeing if it comes out with a remainder of 0. So next one, 2x minus 1 dividing into 4x cubed minus 5x. So 4x cubed over 2x is equal to, doesn't look like two division signs, is going to be 2x squared. Multiply through, you get 4x cubed minus 2x squared. Okay, we subtract, you get 0, and negative 5x. Okay, now here's the issue. I did this, and we have now an x term and an x squared term. That's a problem. So what we have to do here, we have to hold the spot for the 0x squared. So that way when we subtract, we're adding constant, we're adding like terms. So 0 minus a minus would be a plus 2x squared. And then we bring down the negative 5x. Right, so the next iteration, 2x squared over 2x is going to be just x plus x. Multiply through, you get 2x squared minus x. Subtract, you get 0. And then you're adding an x, so you get negative 4x. Last iteration, negative 4x over 2x, negative 2. Multiply through, you get negative 4x plus 2. Subtract, you get 0. And you get a negative 2. So you have a remainder negative 2 there. Alright, so now we're going to divide into x squared plus 1 into 9x to the 4th minus 2x cubed. Then we can't forget the 0x squared, the 0x. We have the plus. So we'll start with 9x to the 4th over x squared gives us 9x squared. Multiply through, you get 9x to the fourth plus x, 9x squared. So that comes all the way over here. Okay. And then subtract. All right, so you have 0 here, negative 2x cubed, because think of this as 0x cubed here. You're subtracting 0, so it's just going to be the same. And then a negative 9x squared. Okay. Then we go with negative 2x cubed over x squared. Get negative 2x. Multiply through. You get negative 2x cubed. And then again, plus 0x squared. And then minus 2x. So this is 0. When we subtract these, this would be negative 9 minus 0, so it would be negative 9x squared. And then 0 minus negative 2 would be positive 2x. Now we can bring down the 1. Alright, so now negative 9x squared over x squared gives us negative 9. So this is the final iteration. Negative 9, multiply through. It's 9, so plus 0x. So when we subtract these, we get 0. We get 2x. We get 1 minus negative 9 would be plus 9, so we get 10. So this is our remainder. 2x plus 10. Third one here. 8x cubed minus 27. Oh, let me write down what I'm dividing into it. 4x squared plus 6x plus 9 dividing into 8x cubed minus 27. But like we did before, we have to hold the zeros here. So plus 0x squared plus 0x minus 27. Right, so 8x cubed over 4x squared gives us 2x. Multiply through. The ax cubed plus 12x squared plus 18x. Subtract. Get 0. Get negative 12x squared. Get negative 18x, and then we'll bring down the negative 27. We do negative 12x squared over 4x squared. We get negative 3. This will be the last iteration. Negative 3 times 4x squared will be negative 12x squared. Negative 18x minus 27. We're going to resubtract. We get zeros across the board. So here, a remainder is 0. Which means 4x squared plus 6x plus 9 times 2x minus 3 will equal 8x cubed minus 27. Right. So now that we know that if we get a 0 as your remainder, that it factors perfectly, what that tells us is we can then use this to find zeros. And we can use this to see if a factor factors a polynomial perfectly, and then that would be, or if it is of a factor of the polynomial perfectly, then that would be a term for that 0. All right, so we want to see if x plus 1 or x minus 2 are factors of x cubed minus 7x minus 6. So we're going to do long division with this. X plus 1 going into x cubed minus 7x minus, well, yeah, hold for that 0. So plus 0x squared minus 7x minus 6. So x cubed over x is x squared. Multiply through x cubed plus x squared. Subtract. You get 0, and you get a negative x squared. Minus 7x minus 6. Now a negative x squared over x is a negative x. X squared minus 1. Multiply the minus 1 through. Or I'm sorry, minus, not 1. Minus x. Multiply the x squared through, you get a negative x squared minus x. Subtract these. You're going to end up with 0. The negative 7x plus x would be negative 6x minus 6. So one more now. Negative 6x over x gives us a negative 6. Multiply through, you get negative 6x minus 6. When you subtract it, you get 0. So we know that x plus 1 times x squared minus x minus 6 equals x cubed minus 7x minus 6. So we know this is a factor, which means we know x equaling negative 1 would make that equal to 0. So negative 1 is a 0 of x cubed minus 7x minus 6. Next one would try x minus 2. X goes into x cubed. We get x squared. Multiply through. I forgot my zeros again. Hold this. 0x squared. 7x minus 6. X cubed minus 2x squared. Subtract. You get 0. You get plus 2x squared. 2x squared over x gives me 2x. Multiply through. Get 2x squared minus 4x. You subtract. You get 0. Then negative 7x plus 4x would be negative 3x minus 6. So negative 3x over x is negative 3. Multiply through, you get negative 3x plus 6. We subtract, we end up with a negative 12 as a remainder. So 2 is not a 0, and x minus 2 is not a factor of x cubed minus 7x minus 6. If we have a function that gets factored into x minus c, where c is some value being placed into the function, times q of x, which is q of x will be the quotient that could be dividing the function plus the remainder, then if we plug in c for this, that's going to make that 0. We will get the remainder out. Okay. What that is telling us is basically, if we plug in a value for a number, that's going to give us the remainder. And if that value that we plug in gives us 0, then that's an x-intercept. So let's just look at f of negative 1. We look at negative 1 cubed. Go back down. Yeah. F of negative 1 will be negative 1 cubed minus 7 times negative 1 minus 6. It's going to be negative 1 plus 7 minus 6, which is going to be 0. Okay, that tells us again negative 1 is a 0. Remember, in that first one, this was a factor, and so 0 is negative 1. This confirms it down here. Negative 1 is a factor, or is a 0 of that function. 2, f of 2, is 2 cubed minus 7 times 2 minus 6, which is 8 minus 14 minus 6, which is negative 12. That's what we got before. So 2 going into the function gives us negative 12. Okay, so not only is 2 not a 0, and x minus 2 was not a factor, but now we know for sure f of 2 is negative 12. All right. The other way of dividing these is when we have linear numbers that we're dividing is to use synthetic division. This is a very quick way of doing long division. First thing we do is the number that's opposite of that 1, or in that spot, is what we put into this little box. We'll put negative 1. Then we'll write the coefficients here. Again, we have to make sure we include the zeros if there's a term missing. This is 1x cubed, 0x squared, negative 7x, negative 6. We draw a line. The 1 comes down. We multiply the 1 with the negative 1 and put that underneath the 0. And we add down, so we get negative 1. Negative 1 times negative 1 is 1. Put that on the negative 7. Add down, you get negative 6. Negative 6 times negative 1 gives us 6. That goes on the negative 6. Add down, you get 0. This is our quotient here. We started out with x cubed, x squared, x, and then the constant term. This is x squared minus x minus 6, and then the remainder term. This is your remainder. There's a very quick way of doing these. Let's do with the next one. Put 2 in the box, opposite of that negative 2, and then 1, 0, negative 7, negative 6. 1 comes down, multiply with the 2. Add down, you get 2. Multiply with the 2, you get 4. Add down, you get negative 3. Multiply with the 2, you get negative 6. Add down, you get negative 12. Again, we'll have x squared plus 2x minus 3, remainder negative 12. All right, so everyone know if 3 is a 0 of the function x cubed plus x squared minus 17x plus 15. Well, 3 will be in the box. We'll put in exactly 3 because this is the 0, or the possible 0, not the factor of the possible polynomial. And then the coefficients, 1, 1, negative 17, 15. 1 comes down, 1 times 3 is 3, goes under that second one, you get 4, 12, add down, you get negative 5, negative 15, add down, you get 0. Okay. So what we know now, 3 is a 0 of x cubed plus x squared minus 17x plus 15. X minus 3 is a factor of x cubed plus x squared minus 17x plus 15. We also know another factor, sort of, is x squared plus 4x minus 5. Okay, this started out as x cubed, x squared, x. They always drop down 1. So x squared plus the 4x minus 5. And so we know x minus 3 times x squared plus 4x minus 5 and save, is equal to x cubed plus x squared minus 17x. All right. So if we want to know if 5 is 0, put 5 in the box. Do 1, 1, 17, 15. 1 comes down, multiply by 5, add down, you get 6. Multiply, you get 30. Add down, you get positive 13. Multiply, you get 65. Add down, you get 80. We know f of 5 here is going to be equal to 80. So 5 is not a 0. And x minus 5 is not a factor of the function. All right, so for f of x equaling x cubed plus 6x squared minus x minus 30, we want to show that x plus 3 is a factor of f of x by synthetic division. Now, after this, we're going to keep continually factor this until we find all the zeros. So, first, put negative 3 in the box. And this is to show x plus 3 as a factor. We do 1, 6, negative 1, negative 30. 1 comes down, you get negative 3 when you multiply. You get 3 when you add. You get negative 9. You get negative 10 when you add. You get positive 30. And you get 0. Okay. 3 is a 0. Or negative 3 is a 0. X plus 3 is a factor. And now we have x squared plus 3x minus 10. We can factor that. That's the trinomial that does factor into x plus 5 times x minus 2. So now we know x cubed plus 6x squared minus x minus 30 equals x plus 3 times x plus 5 times x minus 2. We have all our factors, our zeros. Can be written as negative 3, negative 5, and 2. If we ended up with a quadratic that can't be factored, well, there's always the quadratic equation to solve for the zeros. What we try to do is get polynomials to factor down to a quadratic, and hopefully that either factors or we do the quadratic equation. Right, so g of x equals x to the 4th plus 2x cubed minus 13x squared minus 14x plus 24. We want to show that x minus 1 is a factor first. We'll put 1 in the box. We'll write out the coefficients 1, 2, negative 13, negative 14, and 24. 1 comes down, we get 1, 3, we get 3, add down, you get negative 10, you get negative 10, add down, you get negative 24, negative 24, add down, you get 0. So x minus 1 is a factor. We are left with x cubed plus 3x squared minus 10x minus 24. Okay? Now, we want to show that x plus 2 is a factor as well. We don't want to go back and start with the original. We don't want to do that. We want to take, if x plus 2 is a factor of the original, and we haven't taken that factor out, it's still a factor of this one. So we'll use that instead. So we'll put negative 2 in the box. 1, 3, negative 10, negative. Actually, just keep it in the line down too if you wanted. So 1 comes down, multiply with negative 2, you get negative 2. Add down, you get 1. 2 again, and down you get negative 12, 24, and you get 0. So now we get down to x squared plus x minus 12. We know that x plus 2 is a factor. So now we want to find and see if this quadratic factors. Well, that factors into x. Let's see here. Plus 4 minus 3. Those are your last two factors. So our function x to the fourth plus 2x cubed minus 13x squared minus 14x plus 24 factors into x minus 1, x plus 2, x minus 3, x plus 4. So your zeros are 1, -2, 3, -4. So your solution to that function equaling 0 is x equals 1, x equals -2, x equals 3, and x equals -4. So now let's use this in going back to what we did in the last section. If we have a graph that's x to the fourth plus 2x cubed minus 3x squared minus 4x plus 4, we have a maximum number of zeros as 4. So that's going to be how many factors we try to get this into. Maximum of turning points is 3. This is even and it's positive, so it's going to have n behaviors that go up directions. If you plug in 0, we are going to get 0, 4 as your y-intercept. And the first thing we got to do is we got to start by breaking this down. Now it tells you that one of the zeros is x minus 1, and it has a multiplicity of 2, which means it can be factored out twice. Let's do it the first time. So we'll put 1 in the box. 1, 2, -3, -4, and 4. 1 comes down, you get 1, 3, 3, 0, you get 0, -4, you get -4, and then 0. So x minus 1 is one factor already. Now we'll keep going with this. 1 comes down, multiply that, you get 1. Add that, you get 4. Multiply, you get 4. Add this, you get 4. Multiply it by 1, you get 4 again. And then add, you get 0. So that shows that it's a second factor as well. And then we have x squared plus 4x plus 4 left over as the quadratic. That factors into x plus 2 times x plus 2. So our function here, x to the fourth plus 2x to the third minus 3x squared minus 4x plus 4 factors into x minus 1 squared x plus 2 squared. So we have zeros that are 1 and -2 with multiplicities of 2 for each, which means they only touch the x-axis. So we're going to start with plotting those. 1, -2. Then we plot the y-intercept 0, 4. Then let's get what the n behavior is. It's going to go up both ways. So this is coming down, touching at the x-intercept, coming back up, eventually going through your y-intercept, coming down, touching at the next x-intercept, and coming back up. The graph looks in some way like a W. Alright, in the next video, what we're going to do is look at a way of kind of going backwards with this. So how we can get a function from knowing the zeros. And then we'll go further into this with looking at rational coefficients. So if you have zeros that are not just whole numbers, including imaginary zeros. And let's see, we'll also get into finding a way to narrow down how many possible zeros you're testing, which kind of helps us figure out how to start when trying to figure out how to factor these or what to divide by. All right, I'll see you in that video.